Hi, this is Mrs. Hickman, and today we're going to be going over the integral as a net change. So we're going to be looking back at particle motion. So you're going to be seeing some familiar things such as sign charts and knowing that velocity is the derivative of the position function and that acceleration is the derivative of the velocity function. Okay, so now we're going to go backwards. So let's recap what displacement is. So displacement is the object's position at a time t and is the rate of change. So these are distance units, so like miles or meters, stuff like that. So if s of t, so s is like a displacement graph where the y, you got a y, this is s of t, and then that's t. So the horizontal axis is for t and the vertical axis is s of t. If s of t is a body position at time t, the displacement over the time interval from t to t plus change in t is this. Okay? This part should look familiar because we did that when we used it for the definition of a derivative. The only difference is it's missing the limit as h approaches 0 and h over the bottom. Okay? Displacement at a constant velocity is velocity at time, but we are not at a constant velocity for what we're going to be looking at. What we're going to be looking at is on a curve. So what we're going to do is partition all those curves into little tiny rectangles like Riemann sums. And if you get those little rectangles close enough, it's going to look like it's constant velocity, which turns us to that of the integral. So if you look here, you see that Vt of k, so this is everything I just explained. So Vt of k, this is setting up the interval, which makes it into this. So, which is going to be the integral from a to b v of t dt. That's how you find the displacement. Okay? But if you're looking for like the displacement, you also have to put into account the initial position. So to find the displacement, it's going to be the initial position plus v of t dt. Okay, and that's how you would find that. Okay, describing the motion. So you're going to want to find, you're going to be given like an interval of what this is. So you're going to have 0 is less than or equal to t is less than or equal to 5 for the first example. So you're also going to want to find the final like b. So you're going to want to find v of a and v of b. Then you're going to want to set velocity equal to 0 and solve for t. That is going to tell you when it's rested. And then you're going to do a sign chart to determine where velocity is positive and negative. Where velocity is positive, it's going to the right. Where it is negative, it is going to the left. And where it is 0, it is rested or changing directions. Okay? Determine ending velocity, that's what that is right there. Okay, so I do have an example. So, suppose ds over dt, that is the velocity, equals t squared minus 8 over t plus 1 squared centimeters per second. So, let's describe the object's motion. Okay, so let's find v of 0. So we have v of 0 is going to be 0 squared minus 8 over 0 plus 1 squared, and that's going to give you negative 8. So as of right now, this particle is moving left at 8 centimeters per second. Okay, let's find the endpoint, which, this is going to be where 0 is less than or equal to t is less than or equal to 5. Okay, now we're going to try to find v of 5. Well, we will. So that's going to be 5 squared minus 8 over t plus 1 squared. And that is going to give you 24.8 centimeters per second. Okay, this is positive, so the object is moving to the right and ending at that velocity. So moving to the right. Okay, so now let's see what the object is at rest, and we find that by setting this equal to 0. So you have 0 equals t squared minus 8 over t plus 1 squared. You can get rid of fractions by multiplying by t plus 1 squared everywhere, and you'll get 0 equals t squared times t plus 1 squared minus 8. Okay, you're going to solve for t. So I'm not going to worry about, if you were to, you could expand this, do t plus 1 times t plus 1, which will give you t squared plus 2t plus 1. Distribute the t squared, so you're going to get a quartic root minus 8, okay? But you're going to have to use your p's and q's to find it. But for more complicated ones like that, we are just going to go straight to this. So we're going to type the equation in here. So you got x up to minus 8 over x plus 1 squared. And we got a window, -5 to 5, 1 to 10. Let's see what it looks like. Okay, there is a graph there. I just don't know how. Okay, so see the graph right there? So we're 0 to 5. So I'm going to find the 0. So I'm going to do second trace. And you're going to go to 0. Okay? You're going to go before you cross. Hit enter. And then cross the horizontal line. Hit enter again. And then enter again. Okay? And you're going to get 1.25. So t equals 1.25. So the object motion is going to be, the particle has an initial velocity of 8 centimeters per second to the left. Then it slows to a stop at t equals 1.25. Then it's going to move right with increasing speed, reaching at 5 seconds a velocity of 24.8 centimeters per second. So that's all that happened here. All right, what's it asking for next? So it's saying if s is 0 equals 9, find the position at t equals 1 second. So this is where you see s of t. S of t is going to be the initial position, so s of 0, so it's going to be 9, plus the interval of 0 to 1 of t squared minus 8 over t plus 1 squared dt. Okay. So that's going to be 9 plus 0 to 1 of t squared dt minus, you can go ahead and put the 8 on the outside if you want to, 8 0 to 1 t plus 1 to the negative 2 dt. Okay? So this one is kind of a u substitution. U is t plus 1, so du is going to be just 1 times dt, which you have. Okay? So all you got to worry about is the power here. So you got 9 plus 1/3 t cubed minus 8 t plus 1 to the negative 1 over negative 1. 0 to 1, which is going to be 9 plus 1/3 t cubed plus 8 over t plus 1. Okay? Okay, now you're going to do 1 to 3. Okay, so I'm just going to put that, so you don't, not worrying about the 9 with the 0 to 1. So you're going to have 9, which is right here, plus 1/3 times 1, which is 1/3, 1/3, 1 cubed, plus 8 over 1 plus 1, minus, so this is f of 1 minus f of 0, so you're going to have 0 plus 8 over 0 plus 1. 9 plus 1/3 plus, so that's going to be 8 divided by 2 is 4, so that's going to be 12/3. This is going to be 0 plus 8 over 1, which is 8, minus 24/3. And this is going to be 27/3. Okay? And that is going to give you 16 over 3 centimeters per second. And then when you do this, you have to multiply by time. That's a S. Times a second. So your final answer is 16/3 centimeters. Okay? So when you do integrals, you got to multiply by the time, which is going to be in seconds. Okay? Let's look at another one. So let v of t equals 6t squared minus 18t plus 12 on an interval 0 to 2. So we're going to determine when the particle is moving to the right, left, and stopped. So let's find our initial velocity. Equals, so v of 0, so that's going to be 0 minus 0 plus 12 is positive 12. Okay. Okay. And then let's determine where it's at 0. So we're going to do 0 equals 6t squared minus 18t plus 12. Factor out the 6. Plus 2. Factors of 2 that add to get negative 3. That's going to be negative 2 plus a negative 1. So you're going to get t minus 2 equals 0. And then t minus 1 equals 0. So the object is at rest at t equals 2 and 1. Okay? And 2 is actually up here, so we already know what our endpoint is. So let's check using a sign chart, because this is factorable, so we can do that. Okay? And I'm going to use this right here. Okay? So I need a number between 0 and 1. I'm going to pick 0.5. So you got 6 times 0.5 minus 2 and 0.5 minus 1. So a positive times a negative is going to give you a positive number. Pick a number between 1 and 2. 1.5. 6 times 1.5 minus 2 and 0.5 minus 1. So you're going to have a positive times a negative times a this is 1.5 times a positive, which gives you a negative. Okay, so the particle is moving right. Particle is moving right from 0 is less than or equal to t is less than 1, left at 1 is less than t, less than 2, and stopped at t equals 1 and t equals 2. Okay? The only defined point here can only be 0, because it's going to the right, and then around 1 is when it goes to the left, because it stops and then changes direction. Okay, so we're going to find the displacement if s of 0 equals 3. So that's going to be s of t is the initial position, which is going to be 3, plus 0 to 2, so we got a to b, of 6t squared minus 18t plus 12 dt, which is going to be 3 plus, So t cubed over 3. So 6 divided by 3 is 2. T cubed minus 18 divided by 2 is 9. Okay. F of b minus f of a. 2 times 2 cubed minus 9 times 2 squared plus 12 times 2 minus f of 0, which is going to be 0 because everything has a t in it. So you got 3 plus 24, or 2 times 8 is 16. 9 times 4 is 36. And 12 times 2 is 24. Okay? So you're going to get 7 meters. Okay? Now we're going to find the total distance. And to find the total distance, you're going to be using the absolute value. Okay? So if we were to graph this function, it's going to look something like this. So it's going to be positive. So it's going to be above the axis here, and then it crosses at 1, and then it goes down. So let's see if I can draw that. So let's see. It's 0 at 0 and 1, or 1 and 2. Okay, we said it is above the x-axis right here and below from 1 to 2. So it probably looks something like that. Okay? So when you're finding the integral of this, you're looking for this area. You're looking here and here. Okay? So this is the positive area minus a negative area. So that's how it's going to work with absolute value, because this, in essence, comes up here to look like that. But you have to multiply by a negative. So we're going to have S equals 0 to, or total distance is going to be 0 to 2, 6t squared minus 18t plus 12 dt. So it's positive from 0 to 1. Okay. And then you could either subtract it here or multiply the whole thing by a negative on the other side. 1 to 2. So I already put in the minus sign right here. 16t squared. Oh, that's not 16, it's 6. 6t squared minus 18t plus 12 dt. Integrate. Okay, so we already integrated in the last one, so you're going to get 2t cubed minus 9t squared plus 12t, 0 to 1, minus 2t cubed minus 9t squared plus 12t from 1 to 2. Okay, so I'm going to go over here. So you got f of 1 minus f of 2. So that's going to be, well, f of 1 minus f of 0. So that's going to be 2 minus 9 plus 12. So you got 2 minus 9 plus 12 minus f of 0, which is just going to be 0. And now we're here. Minus f of 2 minus f of 1. So you're going to have 2 times 8 is 24. 9 times 4 is 36. 12 times 2 is 24. Wait, hold on. Sorry, 2 times 8 is, 2 times 8 is 16, not 24. I don't know why I keep doing that. Minus f of 1 which is 2 minus 9 plus 12. Okay, so you got 2 minus 9 plus 12 is 5 minus 16 minus 36 plus 24 minus 5 is negative 1. So you get 6 meters is the total distance. Okay, so lastly we're going to be doing the velocity of an object's position. So this is the same thing, except you can find things given the acceleration. Okay, so velocity is the object's derivative of the position function at s of t with respect to the line. You already know that. And from what we did earlier, when it's positive, it moves right. When it's negative, it moves left. When it's 0, there's no movement. And again, so to be able to find the velocity, so you can find the velocity if you're given the acceleration, but it has to be constant. So again, you got to partition things down to very, very tiny rectangles or trapezoids, and then to make it look like it's constant. So then you can kind of trick the formula into doing like this. So velocity looks the same as displacement. The only difference is the initial velocity, not the initial position, plus integral a to b of a t dt. So a car is moving with initial velocity of 5 miles per hour. It accelerates at the rate of a of t is 2.4 t miles per hour per second. Okay, remember acceleration is like meters per second squared, so you're going to have 2 times. For 8 seconds. So how fast is a car going when 8 seconds are up? So this is our integral, so we got 0 is less than or equal to t is less than or equal to 8. Okay? So to find the velocity, you're going to do the initial velocity, which is 5, plus 0 to 8, 2.4 t dt. So that's going to be 5 plus 1.2 t squared, 0 to 8. 5 plus 1.2 1.2 times 8 squared is 76.8 minus 0 plus 5, and that's going to give you 81.8 miles per hour. Okay? So it's like if you technically, 2.4 t miles per hour per second, but then you multiply by a second, and then the second goes away. Just like we did earlier in that one problem we did. Okay? Lastly, how far did the car travel in 8 seconds? So you're looking for the total distance. So you're going to do S equals 0 to 8 of V of t dt. Okay, so our velocity is 1.2 t squared. So it looks like this. Something like that, okay? So it's all positive, so you don't got to worry about subtracting anything. Okay, and the initial position is going to most likely be 0 because the slope is 0 right here. So it's going to be, so the position function is going to look like this. Like that, okay? So it's starting at 0. So you could say 0, which is the starting point, plus 0 to 8. Okay, 0 to 8. 5 plus 1.2 t squared dt. I guess you don't need that then. So that's going to be 5t plus 0.4 t cubed 0 to 8. So you get 5 times 8 plus 0.4 times 8 cubed minus 0. And you're going to get 244.8 miles per hour times seconds. Okay, because you got to multiply by a time every single time. So how you get rid of that, you got 244.8 miles per hour. In 1 hour, there's 3,600 seconds. And your answer is going to be 0.068 miles. Okay? So your homework is going to be 1, 3, 6, 7, 9, and 11. Okay? And that's going to be due Monday at the beginning of class. Thank you. Enjoy your weekend, and I hope that was able to help. Goodbye.